Okay students, this is the third video, and in the third video we will solve question 3. This is what question 3 reads at. Consider the system as previously specified in question 1. The cantilever beam fixed on the left hand side with the UDL across it, and use this to determine the most correct expression for the vertical difference between the vertical line passing through a point B with a coordinate 2/3 of L and the intersection with the tangent passing through a point A with a coordinate of 1/3 L, and the vertical line passing through point B when XA is less than XB. B is on the right hand side. That gives an explicit expression accounting for the correct sign notation for the vertical difference in terms of Q and L, noting that XA is not XA, XB is not XB. Hint, the question is asking that you calculate TBA and not TBA using the moment area second theorem. And it allows you to use the expression from the textbook if you couldn't actually solve for the expression. And then having solved for that, we then have to choose which is the most appropriate answer. There's a negative answer for A, a negative answer for B, a positive answer for C, and a negative answer for D. So let's solve the problem for question 3. Okay. Okay, so we draw the problem. There is a cantilever beam with a UDL. The beam fixed to the wall would deflect in that form. The question is saying that there are 2 points along the length of the beam it says 5 centimeters. 2/3 of 5 centimeters is about 3.3. And then 1/3 of 5 is roughly 1.6 centimeters. So about 1.5, 1.6, roughly there. Okay. Okay, so this is the beam deflection. There's a point XA, 1/3 of the distance. There's a point XB, 2/3 of the distance. There is a vertical line passing through the point B, like so. That's the intersection. At the point A, there is a tangent. So this is a horizontal line passing through the point where it is fixed, and at the point there is a tangent. There is a tangent. That tangent intersects with the vertical line at a point over here, and the question is asking you to work out the difference between these 2 points over there. So effectively you just draw a horizontal line. And physically, that is what the question is asking you to calculate, TBA. Observe that the bending moment expression from our question 1 was this formula that we're going to use. So we'll just write this down. M is equal to minus a half QL squared plus QLX minus a half QX squared. And according to this expression, that's going to be a negative. That would be a negative term. It's the same as in the textbook. The textbook gives you an expression for the bending moment. If it is positive, and if it's negative, it would be the other way around. And the textbook specifically says if the bending moment is negative, then the tangential deviation would be negative. It's spelled out in the textbook. So that means TBA would be a negative number, because the bending moment M is a negative bending moment. So that's according to our textbook. And then the hint of the question specifically says, please work out TBA. So the question, the hint actually tells you what you need to work out, and tells you can use the previous bending moment and gives you the values over there. So using the formula in the textbook, we will say TBA is equal to the integral from a to b of x1 m over ei dx. That is what we have to work out for question 3. The distance x1 would be that value. So we have an origin, x is equal to 0, x is 1/3 L, x is 2/3 L, x is equal to L. The distance from point A to some point over here would be x. Okay, and we have to work out what is xa. Looking at that, we can take the distance from 0 to x. We can subtract the point xa. That will give us this little distance, 1 in double arrows. We would add the x, 1, and that would equal to the total distance between the two of them, between A and B. So according to this diagram, what we would have is x minus xa plus x1 is equal to xb minus xa. We can use that to solve for x1. That would give us the expression for x1. We've already got the bending moment expression. Put this into that, put that into that, and then work out the integral. So that's effectively all we need to do for question 3, and then match the terms to decide which is the most appropriate answer from the options A, B, C, D in the question. So let's go ahead and do that. We can substitute the known information, and that will give me TBA is equal to integral xa to xb x1 m over ei dx which is equal to the integral from 1/3 L to 2/3 L, open bracket, xb is 2/3 L minus x, and then put in the bending moment expression, minus a half QL squared plus QLX minus a half QX squared divided by the flexural rigidity EI. Integrate that with respect to x. Right, so we just have to expand and then integrate and determine what the answer is at the end of the day. Okay, how do we do that? We have a constant times the terms in square brackets, and we have minus x times the terms in square brackets. Flexural rigidity is constant, we can take this out of the integral. So we can take out the 1 over EI. We then integrate from 1/3 L to 2/3 L, open the curly brackets. Now 2/3 L times minus half, that would be minus 2 over 3 times 1 over 2 is minus 1 over 3 QL cubed. And then 2/3, so plus 2/3 QL squared x minus 1/3 QLX squared, and now multiply the minus x into all of that stuff. So I would say that would be plus a half QL squared x minus QLX squared plus a half QX cubed. Integrate. We've got a constant, we've got a coefficient for x, coefficient for x squared, coefficient for x, we can add these two. Coefficient for x squared, we would add this. Coefficient for x cubed by itself. So we'd simplify by collecting like terms. So that would be 1 over EI, integrate from 1/3 L to 2/3 L, open the curly bracket. The constant would just be minus 1/3 QL cubed. We've got for the x 2/3 QL squared and a half QL squared. So 2/3 plus a half would give us an answer. Alright, so using our calculator, we would have 2/3 plus 1 over 2 would give me an answer of 7 over 6. So that would be plus 7 over 6 QL squared x. Okay, and then we have to add the terms with x squared. We have minus 1/3 and minus 1, which would just be minus 4 over 3. Minus 4 over 3 QL x squared, and we just have a half QX cubed plus a half QX cubed. Right, and now we have to integrate that. We can just take the antiderivative. So that would be 1 over EI, open a square bracket, minus 1 over 3 QL x cubed x, integrate 7 over 6 QL squared x, integral of x is x squared over 2, So that would be 7 over 12 plus 7 over 12 QL squared x squared minus 4/3 QL x squared. Integral will be x cubed over 3. 3 times 3 is 9. So this would be minus 4 over 9 QL x cubed. Integral of a half qx cubed. Integral of x cubed is x to the 4th over 4. 4 times 2 is 8. So it would be 1 over 8 qx to the 4th power. Put in the ranges from at the bottom 1/3 L all the way up to 2/3. Put in the data and expand. So this would be 1 over EI, open the square bracket. X at the top is 2/3, so minus 1 over 3 times 2 over 3 would be minus 1 over 3 times 2 over 3. We would have to work it out. Minus 1 over 3 times 2 over 3, which would be minus 2 over 9. Minus 2 over 9. QL to the 4th power. Alright, minus 2 over 9 QL to the 4th power. 2 over 3, we have 7 twelfths QL squared x squared. X would be 2/3, 2/3 L squared would then be 7 over 12, 7 over 12 times 2 over 3, 2 over 3 times 2 over 3, which gives me 7 over 27. So that would be plus 7 over 27 QL to the 4th power. QL squared, L 2/3 L would be L squared, L to the 4th power. Then I would put in minus 4 nines QL x cubed, 2/3 L cubed. So that would be minus 4 over 9 times 2 over 3 times 2 over 3 times 2 over 3, and that would be minus 32 over 243 QL to the 4th power, and then I would have to add the last term, 1/8 QX to the 4th power. So 2 to the 4th power, 2 to the 4th power is 16. 3 to the 4th power is 81. So it would be 1 over 8. 3 to the 4th power, 3 to the 4th power is 81. 2 to the 4th power is 16. So it would be 16 over 81. So 1 over 8 times 1 over 8 times 16 over 81 is 2 over 81. Alright, let's check that. 1 over 8 times 2 over 3 times 2 over 3 times 2 over 3 times 2 over 3, yes, plus 2 over 81 QL to the 4th power. Subtract. Okay, we've got minus 1/3 times minus 1/3, which would be minus 1/9 QL to the 4th power. And then we would have 7/12 times 1/3 cubed. So 7/12 times 1/3 times 1/3, which is 7/108. QL to the 4th power minus 3 cubed is 27, so it would be minus 4/9 minus 4/9 times 1/27 times 1/27, which would be minus 4/243 QL to the 4th power plus 1/8 times QX to the 4th, where X is 1/3. So 3 to the 4th power, 3 to the 4th power is 81. So it would be 1/8 times 1/8 times 1/81, which is 1/648 QL to the 4th power. Just work it out with the calculator to get the answer at the end of the day. 1/EI, open the square bracket, add everything in the round brackets. So it would be minus 2/9 plus 7/27 minus 32/243 plus 2/81, which is minus 17/243 QL to the 4th power minus the integral of all of this stuff taken together. It is minus 1/9 plus 7/108 minus 4/243 plus 1/648, which is minus 119/1944 QL to the 4th power, close the brackets. Okay, we just have to take the difference. So we have minus 17/243 minus and minus, we add it up, 119/1944, and then we get a final answer of minus 17/1944 QL to the 4th power, which does appear to be correct. Now, we can divide it through to get some decimal places. What do we have? Cancel. 17 divided by 1944 is equal to minus 0.008744.855 QL to the 4th power. According to our options, we have minus 0.008744. Our answer is minus 0.008744 and change. So the answer at the end of the day would be TBA is equal to minus 0.008744 QL to the fourth power. Okay, and that's the answer. We can compare the other answers to see if we made a mistake. The second option was minus 23 over 1944. We can check the answer, the numerical value. Minus 23 divided by 1948. According to this, it would be minus 0.011, which is not close to our value, so we can reject option B. Option C is a positive number, and according to our problem, TBA is a negative number. So option C can be rejected. Option D, minus 37 over 1952, we can work it out. Minus 37 divided by 1952, it would be minus 0.018954. Our answer is minus 0.0087, so it can't be option D. So our final answer at the end of the day is minus 0.008744 QL to the fourth power. And then that is the end of question 3.